Hi guys, so we're almost done with this chapter. This notes is titled System of Equations with Special Answers. What we're going to do today, our learning target, is we're going to understand the different types of answers you can get for a system of equations. We have just spent the past 2 weeks talking about systems of equations, if not more. Almost every single one has looked like this one below. Now, what is the solution to this guy right here? It's pretty easy, isn't it? It's 1, 3. And what happens at 1, 3? Well, at 1, 3, that's where the two lines meet. Now, what does it mean to be a solution to a system of equations? That's what we just said. That's where the lines meet. Okay? But just like with regular equations, this is how a system behaves most of the time, where there's only one answer, or one spot where the lines meet. Okay? But these notes, just like the end of our equations chapter, is not about ones like that. It's about one that happens just like 5% of the time, rarely ever. It happens when systems have no solution, and that should be pretty familiar for us, or systems that have many solutions. So just to summarize everything that we just said on the front here, most systems have one answer or one solution, like that one up there had 1, 3. But there are some that have none, and then some that have infinitely many. All right. So on the next page, I'm going to have us take a look at one that has, well, we can figure it out here together. I'm not just going to give you the answer. So would you pause your video, try these two, and then unpause it after you've graphed them for me? All right, so hopefully that was enough time. So this first one, we got a slope of 2. We got a y-intercept of 0, -1. And the other one, we have a slope of 2. And we have a y-intercept of 0, 4. So when I graph this first one, I probably should have done it in different colors, but when I graph this first one, I'm going to go down here to -1, and I'm going to go up 2 and over 1 a couple times, and end up getting that line. And then the second one, why don't we change colors? It starts at 4 and then goes up 2 and over 1. And where are these two going to touch? We've seen ones like this before. If they're not going to touch at all, we say, how many solutions? There is no solution. And you actually need to say those words. You don't need to say the word parallel. But that is why there is no solution, is because the lines are parallel. Whenever the slopes of the two lines are the same, the lines end up being parallel. And when this is the case, the answer is what we just said up here. There is no solution. So what I mean by that is if you look back and if you look at the slope, what was the slope for both of them? Obviously, it was 2, so there's that. All right, so now let's take a look at if the slope and the y-intercept is the same. What can you tell me about the line? Well, obviously, they're going to be the same exact line. And if they're the same exact line, they're going to be right on top of each other. So hopefully we all have the common sense to know that the lines are exactly the same and therefore have infinitely many solutions. What the Regents is going to tell us to do, though, is they're going to disguise the lines by not putting them in slope-intercept form. And I've definitely seen this a ton. So when we flip to the next page, you guys will see what I mean. Like, they'll give you one of them that says y is equal to 2x plus 3, but then the other one looks a little bit weird. To disguise the two lines that are exactly the same, the lines will typically be a multiple of each other. What I mean by this is that a line that's the same as y is equal to 2x plus 3 is, well, what do you think I multiplied each one of those things by? Obviously 2, so that last one's going to be 6. And this is the same skill that we use when using elimination, because all we did with the second line is multiply by 2. can you make another line that is the same as y is equal to 2x plus 3? So why don't you pause the video, think about it for a second, and try to come up with another line that's not 2y is equal to 4x plus 6. That's the same as y is equal to 2x plus 3. So go ahead and do that now. All right, so hopefully that was enough time. Another one that pops in my head is 3y is equal to 6x plus 9. You could do 5y is equal to 10x plus 5 times 3 is 15. You could even do tens. 10y is equal to 20x plus 30. Obviously, I can't check all of yours, but hopefully you were able to follow directions pretty easily there and just multiply every single thing by a number. So let's take a look at some questions like this that I've seen in the past. So this first one right here is consider the pair of equations. What is the relationship, if any, between the two equations? So hopefully everyone can see that the bottom one is just the top one, but everything is halved. Or you could just double the bottom one, right? So what's the relationship? Either one of those things that I said, you could multiply the bottom one by 2. Okay, something like that. Now it says, does this system of equations have one, none, or infinitely many? Because this is going to be one of the special ones, we know that it's either going to have none or infinitely many. Most of them, remember, will have one, but this one does not. So why don't we do this? Why don't we try to solve it using elimination, like we practiced a bunch the last couple of days? What should I multiply this bottom one by if I want to make it negative 4x? Is there anything I can multiply 2 by to get negative 4? No, obviously negative 2. So let's do that. Negative 2 times 2x is negative 4x. Negative 6y is equal to, and then negative 2 times 6 is negative 12. So now when I try to add these up, these make 0, these make 0, and these make 0. So if I really want to write what's left, I'm going to get 0 is equal to 0. So if it's 0 is equal to 0, what do you guys think? Infinitely many or none? Well, hopefully you remember that as long as the sentence makes sense, so in this case, 0 is 0, that does make sense. It's infinitely many solutions. Why? Because of this up here. All right? So it's infinitely many solutions because of that work that we did right there. That'll always be enough of a justification for them. So let's take a look at example 2, the same exact type of thing. Let's see what this one is going to be. It might be a little bit different. So I'm going to take the one that has a bigger amount of stuff, so 12x plus 4y is equal to 8. And I'm going to take a look at that other one, and I'm going to see is there something I can do to get rid of. Why don't we do the y's this time? So how can I get negative 4y's? What can I multiply that one by? What can I multiply that 2 by? Well, obviously negative 2 again. So let's do that. You get negative 12x, negative 4y, and negative 8. And does everyone see how here, zeros across the board? So 0 is 0. So obviously, which one is it from our last example that we just did? The lines are the same lines, so they intersect at every point on the lines. Ooh, spelled that one wrong. All right, so let's take a look at example 3. I think this is the last one, and then I think I have you trying one. So where do these two lines intersect? Let's go back to this. 21x plus 6y is 7. We're going to put the bigger one, and then let's see, what can I multiply this by to get rid of, I don't know, let's do the x's. So I want negative 21 x's. So what do I got to multiply 7 by to get negative 21? Negative 3, which gives us negative 6y. Am I going to get the same exact thing here that I've been getting the whole time? Well, 0, 0. Is that last one 0? What's 7 minus 9? It's a negative 2. So one side says 0, and the other side says negative 2. So you guys tell me, what do you think? Well, obviously, this one is not the same exact thing. It doesn't say 0 is equal to 0. So this is the case that you're going to get where the lines do not intersect. If I were to graph both of these, they would be parallel. And that's what this next sentence is going to say. If the lines have the same slope, but different y-intercepts, the solution to the system is there is no solution, or the lines don't intersect, or something along those lines. If I were to solve both of these equations for y, you would see that the slopes are the same, but the y-intercepts are different. So I have one or two of them for you guys to try here. I think just one. one for you guys to try. So please try that. Pause the video and then unpause it when you are good. All right, hopefully that was enough time. I'm going to take that first one, rewrite that. I'm going to take that second one and multiply it by -2 and end up getting -8x, -4y, and -16. Is everything going to zero out here? It is. And which one is it when both sides are the same again? That's a good review for just equations. The lines are the same line. All right, so here to summarize, the lines are completely the same. They have infinitely many solutions. They're the same slope, but different y-intercepts. They have no solutions. And I probably should have put this one more time. Most systems have how many answers? How many times do the lines usually meet? Usually it's just once. All right, so another type of question that I've seen that's similar to this, that's the same topic but maybe asked a little bit different, is example 3. In this pair of equations, b is a constant. So what can I plug in to there to have infinitely many solutions? So let's take a look at this. What did I multiply 9 by to get 18? Or what can I multiply 3 by to get 6? Well, obviously I could multiply them both by 2, couldn't I? So what do you think I need to multiply 2 by to get b? Well, if these two are both 2, wouldn't it make sense to multiply this one by 2 as well? So what is 2 times 2? 4. B. And again, feel free to check it if you really wanted to. We're not going to waste the time to do that here. So on the next page, example 4, it's the same exact type of question. We're almost done. Last page. What did they multiply 3 by to get 6? 2. What do they multiply 6 by to get 12? 2. And what do you think they need to multiply b by to get a? Oh, 2. So which one says multiply b by 2 and you get a? Obviously that's going to be C. C says 2 times b is a. All right? Last question, we're done. If you can do this one, you understand today's lesson. So Amanda found this equation in her equations chapter of her math book. What is an equation that can be written with Amanda's equation to form a pair of linear equations so it has exactly one solution? The only thing that you could not put for part A is going to be something that's a multiple of 10 and 5. So as long as you have like 3x plus 2y equals anything, 7, you're fine. The only thing you can't have is something like 20x plus 10y is equal to 40, or even something other than 40, okay? Part B says, what is an equation that can be written with Amanda's equation to form so it has infinitely many solutions? That would be this guy up here. Because what did I multiply everything by with this one to get this guy? Obviously just 2, okay? So that's part B. That's it, guys. Thanks for watching, and we are done.